Good day, everyone. My name is Arslan, and welcome to my YouTube channel. The topic we have for today are thumb rules for water in construction. Water is one of the most important, you could say, part of a construction process, and it is the most excessively used material we have during our entire, you could say, the construction phase. And it's used everywhere when it come. For example, if you talk about curing, if you talk about cleaning, if you talk about the concrete process or the screeding process or the plaster or the mortar, everywhere water is used. So water has a very big role, or you could say a very big part in a construction project. All right, so it's very important that every site engineer and every engineer in charge or supervisor must make sure that the water used is appropriate, and it follows the standards that we have. So when it comes to the thumb rules for water on sites, let's look at the first point we have, that water used on construction sites shall be free from injurious amounts of oil, acids, alkali, salts, sugar, organic materials, or other substances that may be harmful to concrete or steel. So the first point says that any sorts of additives or injurious materials or organic matters or chemicals, if it's oils, if it's alkalis, if it's salts, sugar, or any sort of other material, water should be free from it. All right, because anything the water has, it's directly going to affect the concrete and the steel and the strength of the structure. So the water should be free from all injurious amounts of from all sorts of materials. It should be clean, and the color of it should be natural. Similarly, the second point says that potable water is generally considered suitable. So potable water is actually water which is good for human consumption, right? The usual water that we drink. So drinkable water or consumable water is considered the most suitable one for construction. Similarly, the third and the most important point is that the pH of the water should be less than 6. The pH scale, if you go above 7, it gets basic, and if you go below 7, it gets acidic. So the pH of water is 7 itself. That's neutral. So the water which we use on construction sites should not be less than 6. It should not be acidic. Otherwise, it's going to corrode the steel, and it's going to significantly affect the concrete and steel or any other material we have on site. So it should be basic or neutral. These two are the most suitable pH ranges for water. And there are even two simple tests that we could do to compare, uh, you could say, distilled water and any new source of water that we have. So the first test is that the average 28 days compressive strength of at least 3 150 mm concrete cubes prepared with water proposed, which is the new water in a sort of a way, right? The new testing water to be shall not be less than 90% of the average of strength of 3 similar concrete cubes prepared with distilled water. So the proposed water and the distilled water, if you are comparing both of them, or you could say, as a site engineer, you have found out a new source of water on sites. So that would be your proposed water. And the usual potable or drinkable water would be the distilled water. So make 3 cubes of 150 mm and test their compressive strength. And the difference between both of them shall not be more than 90%, right? The difference in the strength of both of them shall be very close and not less or more than 90%. So that's the first test. Similarly, the second test is the initial setting time, which is usually 30 minutes. So again, it says that the initial setting time of test block made with appropriate cement and water proposed. Again, the proposed water is the new source of water. So it should be 30 minutes, right? It should not be less than 30 minutes for it should be 30 or something very close. And the difference between both of them shall not differ by 30 minutes, which is right here in the second last line. So the concrete prepared from the proposed water and the concrete prepared from the distilled water, the difference between their initial and final setting time should not be more or less than 30 minutes. That's the entire point. And these are two simple tests that we could do if we have proposed water or a new source of water inside, and if we have the usual drinkable water, which is written right here, the distilled water. And similarly, what are final words on water? So, in fact, let's change this to seawater, uh, because this paragraph talks about seawater. So what if, for example, we don't have any other option and we have to use seawater? So when it comes to IS 456-2000, it says that seawater, mixing or curing of concrete with seawater is not recommended because of the presence of harmful salts in it. All right. So it clearly says that you cannot use seawater when it comes to concrete because of the presence of harmful salts and alkalis, which would in fact significantly affect the concrete and the steel that we have, the rebar that we have. And the second point says that under unavoidable circumstances, seawater may be used for mixing or curing in PCC only, in plain cement only, which has no embedded steel in it. All right. So if you have no other option and there's no other source at all, then you can use seawater, but for PCC only, not for RCC. All right. So that's a point which every site supervisor must note. And again, it even says that take the appropriate precautions and everything, and make sure, if it's possible, try removing the salts and everything. But that would, again, that's very hard to do because we need large amounts of water on site. But a simple rule of thumb is that don't use seawater, and if you have to use it, there's no other, you could say, option that you have, then use it only for PCC concrete and not for RCC. Similarly, the third point says that, for example, if you have used seawater, then the thing that you would have to change is the minimum cover over the reinforcement, right? So it says that the minimum cover over the reinforcement for concrete permanently under seawater should be 75 mm. So if you're using seawater, then make sure that the cover is 75 mm. I believe a normal average cover is around 25 to 35 to 45. So 75 is a lot, and however, again, it is still not as advisable. That's what's written here, because it would corrode the reinforcement, and even for pre-stressed concrete, it greatly affects its strength and durability. So overall, seawater is not allowed, but if you have no other option, then use it for PCC. And in case you even decide to use it for RCC, then make sure you have a very fat cover on the element, right? For example, the beams and the slabs, that's elements. So make sure you have a thick cover installed, which is 75 mm. And finally, we have the final word on water on construction sites. So water suitable for consumption is generally suitable for construction works. And when concrete work is done, no visible strains or unsightly deposits on concrete surface. So the last point means that, a simple way to check water is that when you're done with concrete work, make sure it has no visible strains on it. All right. These strains are usually white in color. I've personally seen them. And make sure that you don't have any strains on concrete, and make sure that the pH is not less than 6. Make sure it has no alkalis or salts inside, and make sure that the water is consumable water. Human consumable water is generally suitable for construction sites. So that's the final word on concrete. And for example, if you're using seawater, then make sure you only use it for PCC. And in cases of RCC, then make sure that you have a 75 mm of minimum cover installed on the element of the structure, right? On the different elements that we have. So make sure you have a 75 mm cover on it. So this was again a very short and a useful topic when it comes to the usage of water on construction sites. I hope you guys learned something from it, and I hope you enjoyed the video. So stay tuned with us for more simple and easy videos. I'm going to make things as simple as possible. That's my main aim. All right, so have a good day.